Okay, this is from your workbook. This is number 14 from the homework part of your workbook. So we're going to select U, and U is usually the part of the function that's the most difficult to get. It's usually something raised to a power, right? U substitution is our answer to the chain rule. So I'm going to make U x minus 4. And the question is, well, how do you know it's x minus 4 and not x squared? Generally speaking, so if I made u x squared, then du would be 2x dx, and that really doesn't help me much. So if I make u, x minus 4, let me just make this a little bit thinner, and du is just dx, it still doesn't take care of this, right? But what's nice is, since u is x minus 4, I can solve for x here. So I can say that x equals u plus 4. And so now I have everything in terms of u. So I'm going to rewrite this as u plus 4 squared, remember, because that's x, that's my x, over the square root. In fact, I'm just going to go ahead and write it to the 1/2 power, over u to the 1/2 power du. Okay, let's keep going. Let's clean this up a little bit more. Let's remember, we can only integrate when everything is a separate term, because we can only use the power rule with integration, and we're not there yet. So I'm going to go ahead and expand u plus 4 squared. I'm going to multiply that out, and I'm going to get u squared plus 8u plus 16, the whole thing over u to the 1/2. And I'm going to squeeze my du way up there. Okay, so let me make some room for us here. And I'm going to go ahead and rewrite this way over here. Let's change colors so we can. So that's the same as, now I'm going to go ahead and divide everything. I have one denominator. I'm going to divide everything by that denominator. So u squared divided by u to the 1/2, you just subtract the exponents. That's just u to the 3/2 plus. So now 8u to the first, right, divided by u to the 1/2. Again, I'm subtracting the exponents. 1 minus 1/2 is 1/2. So now I have 8u to the 1/2 power. And 16 divided by u to the 1/2. Well, there is no u here, so I'm just going to write this as 16 over u to the 1/2. But remember, you can write this as 16 times u to the negative 1/2. So that's actually what we're going to do. So plus 16 times u to the negative 1/2 du. Okay, so now we can actually integrate. So let me go ahead and make us some room. The hard part's done. The hard part is done. Okay, so now I'm going to have u to the 5/2 over 5/2 plus 8u to the 3/2, over 3/2 plus 16u to the, let's see, 1/2 over 1/2. Okay, so let's go ahead and we can again clean this up, and let's see what it gives us. So this ends up being 2/5 u to the 5/2. I should put a plus c here. Okay, and let's see, 2/3 times 8, that's just 16/3. So plus 16/3 u to the 3/2. And 16 divided by 1/2 is 32 u to the 1/2 plus c. And our final step is to go ahead and reinsert what we said was u, which in this problem was x minus 4. So let me just do that in a different color. Here we go. All right, so our final answer, 2/5 x minus 4 to the 5/2 power. Oh my gosh, there we go. Plus 32 x minus 4. I know it barely fits, but the hard part's over. I think you get the idea. Let's do some trig problems on the same page. Let's take a look at this one. I don't want people to blindly say, oh, when I see a trig function, then u is just going to be that trig function. No, u is going to be whatever's difficult to get to. And in this case, there's only one trig function. So I'm going to make u this x over 2, which, by the way, I hope we recognize is the same as 1/2 x, right? That's the same thing. So my u here is x over 2, or 1/2 x. And my du is just going to be, dx. I'm sorry, x dx. I'm sorry, just 1/2. I'm sorry. So just 1/2 dx. And the only thing we have to do is just adjust for this 1/2 by multiplying both sides by 2. So 2 du equals dx. Okay, I'm going to put this 2 out in front, and it's cosine of u du. And what is the, let's see, when I integrate 2, this ends up being the sine of x over 2. I'm kind of just resubstituting because we're just about done. Plus c. And we're done. So 2 times sine of x over 2 plus c. Okay, let's find another one. Okay, so here you might wonder, well, what should I use for u? Well, so let's try and kind of think out loud. Let's try and see what happens if I make u just 4x, and I make du just 4 dx. Maybe that's what you're thinking. And then you adjust. Okay, so then if I try to integrate, I don't really have a rule that helps me integrate sine of 4x times cosine of 4x, right? The only rule I have is the tangent of x times the secant of x. That's the only 2 trig functions that when they're multiplied together, there's a rule to help me integrate. So selecting this u was a mistake. All right, so let's try again. What happens if I make u, let's say, sine of 4x? Let's try that. How do I know it worked if I get the rest of this in my du? So let's give it a try. If u is the sine of 4x and du is going to be, let's see, the derivative of that is going to be 4, remember the chain rule, times the cosine of 4x dx. Yeah, I got that cosine 4x dx back. The only thing I have to adjust is divide both sides by 4. Okay, so that works. So let's get started. I'm going to put the 1/4 out in front, and I'm going to integrate u du. Okay, and that's going to give me 1/4 u to the u squared over 2. And my final answer is going to be 1/8 sine squared of 4x plus c. Now, that's one answer, and that's correct. But some of you are probably thinking, well, how do you know? Because cosine of 4x as u would also work. Okay, and let me show you. So in this particular problem, there are two correct answers. Okay, so let's say I make u cosine of 4x. What's the derivative of cosine? Negative, whoops, chain rule, negative 4 sine of 4x dx. Well, same thing. I got my sign back. I just got to adjust. So the negative 1/4 goes on the outside, and it's still u du. And I'm going to go ahead and integrate negative 1/4. Same thing, u squared over 2 plus c. And my final answer is negative cosine squared over 8 plus of, 4x plus c. So these are two different but correct answers. Okay, I hope this helps.